afternoon, I'm Sangeun and I'm a PhD student at Sangeun University. Before the start of my presentation, I appreciate the WiML committee for inviting a contributed talk. So, at the start of my research, we focused on how LLMs can think more like humans. Large language models are the driving technology behind the modern text-based AI agents. Recently, LLMs has advanced rapidly and are being used across many domains, including our own work. Because LLMs have broad knowledge and reasoning ability, we naturally want them to make decisions in complex tasks. However, despite our expectations, LLMs still struggle with complex multi-step decision-making, especially in situations where they need to react to the changing environment with multi-turn interaction. So this suggests that we need a more structured way to guide LLM decision-making. Our mechanism is drawn from dual process theory of cognitive science. It states that people use System 1 and System 2 thinking according to the brain power. And this mechanism leads to the hierarchical decision-making, which categorize and split decisions into rules according to the level of thought required. So this model of hierarchical mechanism is at the core of our proposed solution. Therefore, we propose the multi-skilled, multi-turn, multi-agent framework to solve complex tasks. Here is our architecture, and there are two kinds of LLM agents. System 1 divides a task into the sub-goal, and System 2 generates the low-level actions to solve a sub-goal. Let's suppose that the task is to melt ice cream. The task goes to System 1, and System 1 generates the sub-goal like navigate to the kitchen. This sub-goal is passed to System 2, and System 2 generates the detailed actions like open the door and go to the kitchen. When the sub-goal is achieved, System 2 calls System 1, and System 1 generates the next sub-goal like prepare tools. They repeat this until the task is solved or they hit the step limit. This is our central idea of proposed solution multi-skill. If you'd like to know more, please visit our project page by scanning the QR code at the top or visit our poster tonight. Thank you for listening.